In this example, we want to trace or copy the graph of the given function, f, and then assume that the axes have equal scales, and then sketch the graph of the derivative below it. So, we know that the derivative is estimated by drawing a tangent line at the point x, f of x, and approximating its slope. First thing we want to do is look for horizontal tangent lines, and these are where the x-intercepts of the derivative function will be. We do not have any horizontal tangent lines for this graph. And then next two, it says look for corner, sharp points, vertical tangents, and these cause a discontinuity in the derivative function. Well, in this case here, there is a vertical tangent that's located right here. And a vertical tangent then confirms that we have a discontinuity. So let's take a look at some of the graphs that we have. So here are your examples of discontinuities. A corner, okay, here's a discontinuity of a hole there, and then we have a vertical tangent. So the vertical tangent here is what we have here, and therefore that's going to create an asymptote on the y-axis. So therefore, the first thing we want to do is to draw a vertical tangent on our axis. So on our y-axis at 0, we're going to have a asymptote. And again, there's the asymptote because of the vertical tangent. Okay, now let's take a look at the intervals on both sides of this function. If we take a look at step 3, the derivative function will be positive where tangent lines of the function have positive slopes, and negative where the tangent lines have negative slopes. Okay, so here we have our graph. Okay, so this graph here, you can see that in the interval from here to the vertical asymptote, okay, what's happening? Well, we can see here that we have slopes, okay, that are positive, and you can see they start increasing towards the vertical asymptote. So that means on the left side here, we have this slopes that are slowly increasing to the vertical asymptote. Okay, now if we take a look at the other side of the graph, between this interval, well, what's happening here? Well, we can see here that the slopes start out quite steep, okay, and then they start decreasing towards the value of 0. So therefore, we would then write the following. We'd say that here it starts increasing, and then it starts going towards the value of 0. And therefore, this graph represents the derivative function of this function here.